Hello guys, welcome to my YouTube channel. So in this video we are going to create an end-to-end project about recommendation system, but we will be focusing on rating based recommendation system. As I have a playlist, as you can see in my YouTube channel, I have a playlist by the name of recommendation system projects, and there I have covered a lot of project related recommendation like crop recommendation system, music recommendation system, electronic recommendation system. I have also created for all these project websites. Okay, so these are all end-to-end projects. You can see music and job recommendation system, books, movies, Amazon product recommendation system. So the next upcoming videos like this today one, we are going to create projects about all recommendation system. All recommendation system mean that today in this video we will be covering rating based recommendation system. We will be using a dataset, Amazon product reviews. It is a quite big dataset and quite interesting dataset. In the next video we will be covering rating based recommendation system, but we will be using clustering techniques like k-means. And in the in third video we will be covering user based recommendation system, because there are a lot of types like collaborative filtering. We will also see a different project, content based and hybrid based. So first let me explain you that what is rating based recommendation system. But अभी के लिए आप लोग क्या करो, either you can open up Kaggle notebook or Kaggle Google Colab notebook, or you can use your Jupyter notebook. Okay, but the data set that you have to download, that is Amazon product reviews. So if you are using Kaggle notebook, then you don't need to download data. You have just to click on this add button. First of all, you have to open up your Kaggle. Right, just go to your Chrome browser and type there Kaggle. Okay, enter and click on this first link. And for the first time, if you are not logged in, means if you haven't created your account there on Kaggle, you have to create it. After creating, click on this create button and create new notebook. After clicking on this button, you will be redirected like there will be a Jupyter notebook. Now this is quite big data. Okay, so you have to add this data. So click on this add button and just search here Amazon product reviews and enter, and just let me expand it like this. So there are a lot of Amazon product reviews, but you have to select this one, Amazon product reviews by Arham Romi. Okay, Arham Romi. So click on this. There must be a button. Okay, it's not displaying. Just let me show you. Just give me a second. Let me zoom out a bit. Okay, zoom in. This plus button, as you can see, I have already added. Let's say you are going to add this data set. You have to click on this. After clicking on this button, your data will be right here. Right here, this is the data. Okay, this one. So if you expand, and you will see here within this folder we have another folder by the name of reviews.csv, actually a file. So you have to copy this path. After copying, what you have to do, first of all, before starting, you have to import numpy, pandas, and from sklearn.featureextraction.txt you have to import tfid vectorizer, and we will discuss it a bit later. Then you have to import cluster. From cluster technique you have to import k-means. This is an algorithm specially used for grouping similar items. We will see a bit later. And from matrix.pairwise you have to import cosine similarity. Okay, after importing these things, you have to write df will be equal to pd.readcsv, and just by copying the link, select all this. Okay, select all this and paste. And after pasting, you don't need to specify the path, it will automatically detect them. So before understanding a rating based recommendation system, let me show you the data set. Okay, so we have this data set. After typing df data head with first two rows. Okay, there you can see here we have id, product id, user id. Okay, I think the client and the name, profile name there on that specific website. Like let's say this is an e-commerce website data set, so there must be user id, user profile, and there are a lot of things, but we will be taking only this id, the product ID, and the score, and we will explain these things a bit later. And we will also take summary and text. We need these columns for this project. Okay, we don't need the other things. So before moving forward, what I can do, first of all, what I have done, I have taken ID, product ID, score, summary and text, and I have assigned it again to my df. Okay, so after using head, as you can see here, we have ID, product ID, score, summary, text. Now what are these? Why we take this? So let's understand first of all a rating based recommendation system. So recommendation system we have explained in previous couple of projects, that when you want to recommend the best things, the best items to your users, let's say you are running your website, e-commerce website, and you want, when there a client or user comes on my website and he search a specific product, let's say he's interested in watch. So if he search watch, then our system, our website must be professional or must be able to recommend the best things to him related to his search. And apart from that, there are a lot of other techniques, similarity between user, or we can recommend things on the basis of other users, and we will see that a bit later. But rating based recommendation system is actually when you want to filter or predict rating or preferences a user would give to an item. Okay, now what does it mean? We will understand this thing in Dataset, but it provide personalized recommendation to user based on their past ratings or preferences. Okay, so to understand this thing, this is a mobile phone or any device that you are using, and you have opened up my e-commerce website, and this is a user, this is a user, this is a user, this is a user. They search different products. Let's say this girl searched watch, this one search another product, another product, another product, and for each product they give scores. Scores are nothing but ratings, and this stars, you must have seen these things on social media accounts as well. Okay, so someone give great song, someone give excellent, someone give they share their different reviews about that things. These are scores. We will see that this particular user, how many score he gave to that particular product. Maybe it could be 2 stars, maybe it could be 3 stars. So this is the flow. So before moving forward, first let me show you the data set. So the question when to use rating based recommendation system is very interesting, because if you get project from your company or either on Fiverr or Upwork, they will ask you that you have to use rating based recommendation system. We need rating based recommendation system for this website or for this particular data set. Now in this data set, you have to specifically find those columns that are related to your recommendation system, and that is the first thing. You have to take that column that contains all the product IDs, like this one. These are the product IDs. Then you have to take the score. The score in the sense the rating that particular user has given to that particular product. Someone given 5 stars, someone given 1 star, someone given 4 star, and then you have to take summary. Now these are not for rating based recommendation system. These are actually for content based recommendation system. We will see that a bit later, but we will take these 3 columns. So let's do it. So after analyzing my data, what I have done, first of all, as you can see here, just let me show you. If I show you the shape of data set, as you can see here, the shape of this data set is quite big. Okay, so if you want to use this entire rows, as you can see, it is 5,68,454 rows. This is quite big data, and with 5 columns. So if you want to use this entire data set, then you will not be able on your local machine. If you are using Jupyter Notebook on your local machine, if you have installed GPU, then it is quite good. But there are a lot of notebooks like Google Colab or this Kaggle one that provide you GPU. So just click on this 3 dot and go to accelerator, and there select this GPU P100. Okay, but just for time saving, I am taking the first 10,000 rows from my entire data set. I am going to take from this 5,68,454 rows. I am just taking first 10,000 rows, and I am assigning it to again to my DF. Now if I check the shape of this DF, it will be 10,000 rows. Okay, Now as you can see, we are quite interested in this score because this is the rating that has been given by a particular user to a particular product. So let's analyze it. So what I've done, I've just taken the score column and I've used value counts. It will give me the value counts for all the what we call it, ratings. Okay, actually we have 5 ratings, someone given 1, someone given 2, and there are 3 ratings as well, 4 rating and 5 ratings. So we have actually 5 categories in simple words. Then I have used plot and I specify kind will be bar. Okay, so after running this cell, you can see that the rating that has been given by user, there are a lot of user that has given 5 ratings, and the count of that users are 6,000. So it's mean that in my 10,000 rows there are 6,000 users that they have given 5 ratings to products. And there are also 1500, I think like about 1500 users who has given 4 rating, and there are also 1 rating, 3 rating and 2 rating. Okay, so you can check it as well. Now these are for now, this forget this to summary, because we will be implementing these things in content based recommendation system. So let's talk about rating based recommendation system. For rating based recommendation system, you have to take the necessary columns. Okay, so I needed ID, product ID and score. That's why I have taken this one and I have stored them in new data f that by the name of ratings df. So if I check this one, then you would see these things. Okay, now for that you have to create a pivot table to represent the user item rating matrix. Now what does it mean? So actually rating based recommendation system, in rating based recommendation system you must use this pivot table that has been provided by pandas library. So we will see this thing practically, that what does it mean. So actually it is used to create a representation of user item rating matrix. Okay, and this matrix captures the ratings given by user to different items or products. Okay, and each row represent, this is quite interesting, each row represent in this pivot table matrix a user, and each column represent an item or product. Now what does it mean? So first I would like to explain this thing, then I will show it right here. Okay, this rating matrix. So what I have done, I have just used the rating df in which I have ID, product ID and score, and on top of that I have used pivot table, a built-in function that provide me matrix. Now here you have to specify 3 things: index, columns and values. So what I have done, I've specified that in my data set there is a column ID. You have to tag this as an ID in this new matrix, and you have to specify the product ID. All the product ID values that are 10,000 will be our columns, and this will be quite big matrix. Okay, and values in each product ID, the values will be score that has been given by a particular user to particular product. And if there is no rating in each row, then you have to specify that thing with 0. Let's check it out, and I have stored it in pivot table. So this is the matrix. So this is the ID. Okay, all the IDs, that is product ID. Now here we specify columns as a product ID. So these are the columns, and this will be 10,000 columns. Okay, why? Because we have 10,000 values or rows in product ID. So when you use pivot table and specify columns for particular column, then that column will be according to the size of that column values. Okay, now here each row is nothing but it is a vector. Each row is nothing but it is a user ratings to all products. Now this is first product and this is first user. So this user didn't give rating to this product, this product, but there will be some rows where they must have given either 3 or 2. So in simple word, you have to understand that this row represent all the ratings for all the products for this user. So let's explore it here. So this is product. Let's say we have total 5 product 1, 2, 3, 4, total 4 products. These are 3 users. Okay, now these 3 products, this user hasn't given any rating to all these products. The same thing goes with this user and the same thing goes with this user. But let's say this user has given 3 ratings to this product, so there will be 3. But just for simplicity and explanation, I have taken these things. So the pivot table works like this. Okay, so let's move forward. So now we have a pivot table where each user's ratings for each product. Okay, now what I will do, I will calculate cosine similarity of this pivot table. Now what does it mean? I am going to calculate similar user with similar ratings for each product, and this thing is very simple because scikit-learn provide a built-in function cosine similarity, and here you have to pass the items or the data where you want to calculate cosine similarity. Now in this pivot table we have total 10,000 rows, 10,000 users with 10,000 rows, and each row represent ratings for each user with all the products. So if I use this cosine similarity, so what I am doing, I am calculating this user similarity with this user. If this user given 3 rating to this user and this user given 3 ratings to this product, sorry what I'm talking, let's say this user has given 3 ratings to this product and this user has given 3 ratings to this product, so they are similar. They are similar in case of rating because they have same rating. So we are calculating each user with all other users in case of ratings. Okay, for that I am using cosine similarity. So let's understand cosine similarity. Now cosine similarity is actually a function in mathematics. You must have seen it, that it actually calculate the similarity between 2 vectors. 2 vectors are nothing but 2 items, and 2 items are nothing but 2 products. It could be 2 user, it could be 2 movies, it could be whatever you say. So actually it calculates the similarity between items based on ratings provided in the pivot table, as I have already explained. So the cosine similarity measure the similarity between 2 vectors. 2 vectors are nothing but 2 user ratings for all the products, and calculate the cosine of angle between them. Now let's understand how cosine similarity works. This is user 1 and this is also known as vector. This is user 1 rating for all the products in pivot table, and it is an entire row, you can call it, or you can call it a vector. Okay, now I want to calculate the similarity between first user ratings with second user ratings. So we have to use cosine similarity. So what cosine similarity do? Cosine similarity not directly calculate the distance, it actually calculate the distance by angle. If the angle is 0 between these 2 vectors, the angle is 0 between those 2 users, then it will be similar. If the angle is 90, then they will not be similar. It works like this, and I have also explained this thing in a couple of previous my recommendation system projects. Okay, now we have pivot table, this pivot table. Okay, keep in mind we have 2 things: pivot table where we have a large and big matrix where we have 10,000 users with single row for each user, where we represented all users or each user ratings for each product. And we have item similarity also known as user similarity between in case of ratings. Now these 2 things for now just take that we are going to use user ID, that is 4, and we want 5 products for recommendation. If you want to display 10 recommendation, then you can specify it 10, but for now let's say 5. So let's grab user ratings from pivot table. So what I am doing, this thing quite interesting. Pivot table, I am using location. Why I am using location? Because I want to grab this particular user ratings, that is with ID 4. Okay, so user ID that is 4 and take all its columns. Mean what will happen if this, it will take this one, this entire row. Okay, we are going to take this thing. This is the flow of this line of code. For now just understand this thing, and I am taking not the columns but the values. and I am using a reshape with 1 comma -1 because I am interested in single row, in single instance for this particular user. If I specify id 5, then it will be this row, this vector. Okay, so after typing user rating, now this new array is nothing but it is a 2D array with single row where you will get this user ID rating for all the products. Now I am calculating the similarity between this user rating with all the other items. Okay, that's my goal. So cosine similarity, again I'm using the same function, but this time what I am using, I want to calculate this 4 ID user ratings with all the other users. If this user had 3 ratings for all the products, and in this entire 9,999 users ratings, if in that 9,999 user rating there are users, let's say 500 users with 3 ratings for all the products, so we will take this 5,000 user ratings with this one because they are similar, and we will ignore the other ones. And we are considering all these things with a new variable by the name of user item similarity, because we are taking all those user ratings that are similar to this one, okay, this user ratings, and this will become user item similarity. Now the last thing, this is just we want to display the recommendation. Okay, we are displaying top k similar items. If there are similar items with that particular user 500, but we will not be able to display all these 500 recommendation, we have just to display first 10, or it could be 5. So what I'm doing, I am using this user item similarity, and I am using numpy argument sort. It will sort the recommended users in ascending order, and I have specified negative indexing, but what I need first 5 recommendation. You can type it like this, okay, but I have already a variable by the name of Kim. Okay, if you want to display 20 items, 20 similar users or products, then you can do this thing, but let's say for now this one. Okay, so finally I have this similar item indices. Now these are my recommendation. Now I can use this variable in my HTML template, as we have already seen in previous couple of projects, and these are the similarity. Okay, actually these are the indexes. On this indexes we are getting all the similar users or products for 4 ID particular user. Okay, that's the workflow, and in this way it works. So in the next video, before understanding one more thing that is quite interesting, we will also understand this thing. In the next video, what we are going to do, we are going to use the same recommendation system, rating based recommendation system, but we will be using k-means clustering. Believe me guys, if you have an account on your Fiverr or Upwork, there are a lot of demand on recommendation system, but they want mostly clustering techniques. Okay, they are interested in clustering techniques. You have to use this technique, so we will see this. But what if before using all these things, if my client want that you have to display those products on which there are user has given 3 ratings or above 3, yeah, it's mean that you have your client wants you have to display those products on which any user given either 3 ratings or 4 ratings or 5 ratings, but you don't have to display those items that are less than 3, means 1 rating or someone given 2 ratings. Quite interesting. Okay, so for that what I've done, let me remove this thing, I don't need it. I've defined a function by the name of recommend items. Now this function taking 3 things: rating df, the entire df, that this one, okay, that we have defined, this one, rating df with all these 3 columns. Okay, this function take this data frame, and here I am specifying a default parameter where I am going to specify 50. The goal of my this recommendation system is I have to display 50 items, I have to display 50 products on which there are either 3 ratings, 4 ratings or 5 ratings, but I will start from 3. So I have also used, this is optional, you can directly do it right here. If you use here 3, it will work, but I can use here a default parameter. Maybe in future my client change it that you have to use 4 ratings, so I will simply change it right here. Okay, so ratings df, we are going to filter, we are going to use filter method. So rating df, this one, that are coming into this function, there is a column by the name of score, and there are a lot of rating that are 10,000 rows. Someone given 3, 2, someone 1, someone 5, someone 4, but I am interesting that you have to take those rows or those products or whatever you call it that are on which we have either 3 ratings or 4 ratings or 5 ratings. Okay, we are taking those rows, and we have used here head, and we have just display 50 items. Let's say I am going to display 10 items. Okay, you can directly specify it right here. Instead of these 2 things, if I remove for now these 2 things, you can directly say here 3 and here 10. It will work in the same way. Okay, and after that I'm returning this filtered recommendation, and this will be my top 10 recommendation on which either there are 3 ratings or 4 ratings or 5 ratings. Now let's implement this thing. So outside this function, what I have done, I have let's say I have searched this there is a user on website who searched this product with this specific ID. Let me remove this thing because I don't need it. So in this function, let me remove also these things. Rating df, just give me a second. Yeah, we actually don't need it because we are displaying just, oops, we need only this system. So what I'm going to do, I have called this recommendation items recommendation items function, and I have passed my rating df in which 3 columns: id, product id, score, and there I have just implemented the score where my condition is 3 and above 3. So this will return all these rows. 10 recommended items are 10 rows, okay, on which there are 3 or 4 or 5 ratings. Now here I am checking, maybe it is empty, so I'm just checking. If not recommendation dot empty, then you have to use a loop, and in loop you have to take index row from this recommendations, and there you have to use built-in function iter rows, and I'm just displaying product id, score with row score from this thing. Okay, and if this condition becomes false, then display that there is no recommendation. So after running this, there is an error, ratings df. So it's just because I have to run all the previous cells. So let me run it from start. Okay, let me run all the cells. It will take yeah. So as you can see, I'm getting top 10 recommendation, and I'm just getting there are 5 rating, 4 rating, and 4 rating and 5 rating. Okay, I'm just getting 10 recommendation system. Let's say I am going to increase this thing, let's say 50. Okay, these are the 50 items. Okay, you can display 100. So it's work in this way. So if you have any question for now, then you can type it in the comment section. I will definitely answer. So in the next video we will see the same project but with k-means clustering. I hope you have liked this video. If you have liked this video, then please subscribe to my channel and also like this video. So see you in the next video.